Hello, welcome to this week's Deep Dive. I'm Annie Shuttleworth, meteorologist and presenter here at the Met Office. Now, the weather pattern may not be changing, the rain is not going anywhere, but we have still got plenty to talk about in this week's Deep Dive. Now, if you're new to the Deep Dives, welcome. Please make sure you subscribe to our YouTube channel. We're trying to get to 400,000 followers, so make sure you share this video with anyone you know and anyone else you think might enjoy the Deep Dive that might not have come across it. But if you are new, this is an opportunity to talk about all things weather in detail. We don't always just talk about the next couple of days weather, we talk about things that are interesting. Now this week we will be doing a bit of a special on ensembles. We have just released some new research here at the Met Office, and I'm joined by a very special guest and lead author, Mylne, on that research later on in the show. So make sure you stay tuned to watch that. We'll also have a look at elsewhere. That south shifted jet that's brought this relentless rain has also brought some pretty wet weather to parts of Portugal and Spain, and there's more of that to come. Now, if you're joining us on YouTube, welcome, but you may also be joining us on Spotify, where you can catch all of our forecasts and deep dives, so make sure you check that out if you've not already. So let's move on to the weather. As I said, the south shifted jet stream is the cause of all the rainfall. And here you can see this is the south shifted jet stream. It's a particularly strong jet, actually. You can see that by the quite deep purples, the focus of those arrows. And that's what's been driving areas of low pressure up into the south of the UK. It's why it's been a particularly wet January. Cornwall's wettest January on record, and a particularly wet January for Northern Ireland as well. Now, the reason it's been we've got such a strong jet stream is because of that temperature gradient across the Atlantic. We've talked about that over the past few weeks, but also we've got this big blocked pattern over northeastern areas of Europe, and that's what has shifted that jet stream to the south. And there's very little change through this week. As I said, that south shifted jet stream has brought the UK's very wet weather, but also it's brought parts of Spain and Portugal some very wet weather as well. So we're going to take a closer look at that rainfall in just a moment, because there's a notable rainfall event coming through the middle part of this week. But through the rest of this week for the UK, we've got further rainfall on the way. Actually some snow as well. There's snow warnings, a risk of freezing rain as well as we head into Wednesday. There will be some dry weather actually as we move to Wednesday. We start to see some slightly milder air actually pushing up to the south, a bit of a split picture across the country. Still some very persistent rain across northeastern areas of Scotland. There's been a steady stream of rain across these areas, and further areas of low pressure sitting down to the south and west of the UK. There's some uncertainty in that area of low pressure, as Aidan covered in the week ahead just yesterday, and there'll be more information on that in the forecast over the coming days. But the general trend for the forecast Thursday, Friday into the weekend is for this area of low pressure to be sat out to the southwest of the UK. Series of bands of showers coming up from the south, still a steady stream of rain moving into the northeast, and the driest areas actually across more northwestern areas of the UK. As I said, there'll be loads more details on the UK's forecast in our daily videos, as well as our 10-day trend tomorrow. But I want to focus on the weather elsewhere actually in this week's deep dive for this first few minutes at least. So as I said, that area of that south shifted jet stream has brought very unsettled weather to parts of Spain and Portugal. And let's get that on actually. So you can see, so we've got the blocked high pressure over northeastern areas of Europe. That jet stream has brought a series of low pressure systems, weather fronts into affecting parts of Iberia basically, and by through the next few days, actually this large area, this very elongated area of low pressure out in the Atlantic, it's actually been named Storm Leonardo. You might have heard of it. It's being mentioned in the news a little bit. It was named by the Portuguese Met Service for initially the fact that it's going to bring strong winds to the Azores, but there's also further strong winds and heavy rain set to move into Portugal, and that heavy rain will affect parts of Spain, Morocco, Algeria as well. And it's actually looking like potentially a once-in-a-lifetime rainfall event, in particular for parts of Spain. So that's what the jet stream's doing. let's have a look at how that rain plays out. So it's Wednesday into Thursday. So this area of low pressure, this is the initial low. That's what's been named Storm Leonardo. It does approach the UK, but it is not going to be bringing us stormy weather as per. It's not something we have named. And actually, it's well away from parts of Portugal and Spain, but it's still the impacts of it that will be, those knock-on effects that will be bringing that really wet weather into parts of Portugal, as well as Spain, Morocco, Algeria too. Most persistently Wednesday into Thursday, that's when we'll see the heaviest rain, and then it does remain relatively unsettled as the week goes on, but somewhat dry. It's that Wednesday into Thursday period where they could see some very high rainfall totals. Some areas could see 500 to 600 millimetres of rain falling. So Storm Leonardo weakens as a feature, moves away from these areas, but we continue to see this persistent rain into the weekend. So let's have a look at how those rainfall totals start to build up for those areas. So I'm going to go into the global map, and quite clearly, as soon as I click on here, you can see that area of Spain and Portugal, as well as Morocco, really sticking out to us. That's the 3-hour totals. Let's have a look at the 24-hour total. So the scale changes, so that's why the colours have come down a little bit. So if we go to the end of Wednesday, I'll zoom in on the area a little bit. There we are. We just have mostly capital cities coming up to just get your bearings a little bit. So you can see, yes, we've got the rainfall totals across more southern areas of Spain in particular, as well as Portugal. 100 to 200 millimetres is expected between Wednesday and Thursday, quite widely across Portugal, as well as much of Spain, seeing around 200 millimetres of rain, and so particularly over the high ground. And it's more southern areas of Spain, although it's generally actually quite wet across the whole of Spain. And then on Thursday, topping up onto that, we've got further rainfall across northern areas of Portugal, and then again across more southern areas of Spain and that northern area of Morocco as well, seeing some heavy rain through Wednesday and Thursday. Now, although the rainfall totals actually are less so across parts of Spain, it's actually parts of Spain where we could see the most significant impacts, as well as parts of Portugal too, because their average rainfall for this time of year is lower, so the impacts could be greater. Of course, we've had in recent years some very significant rainfall events happen across parts of Spain. Of course, the floodings in Valencia not too long ago. This is a very different event to that that they should be expecting. This is for river flooding, a widespread area of prolonged rain, rather than those sort of intense downpours that brought the serious impacts to parts of Valencia. So this is a very different beast to that, for those that might be thinking, oh, we've had some of this lately. It's a very different beast. So because we are expecting, I'll just go back to that map actually. If I get on here, we'll just go for the rainfall on here. So it's southern areas of Spain. I just want to show you that that's where we'll see the heaviest rain, and it's the river flooding. You can't see the rivers on here, unfortunately, very clearly, but there's a major river that runs across more southern areas into Seville, across more southern parts of Spain, and it's big, slow reacting rivers that are going to be affected, and that's why we could see some quite major impacts to infrastructure, as well as roads and railway, agriculture too, a major event. Now we can look at the data from that and how the rivers will react. I've got a graph here which I'm going to explain. So here, this is for the river, it's just cut off at the Guadalquivir River across that major river that runs across southern Spain. And this is data from the Copernicus Emergency Management Service. This is for information purposes only. It's not a flood warning. And what this data shows you is it uses the ECMWF, the European rainfall data, the Ensemble data, and puts that into the hydrology model to show you the discharge level of the river. So how much water is in the river at a particular point, location, at a specific point in time. So on the y-axis here we have the discharge, that's in meters cubed per second. Along the x-axis we've got date, as you can see, and on the other axis, unfortunately we can't see it. Oh, I'm gutted. I should have checked that, I'm really sorry. But here we have once you get into the pink here, this is the return period, so how often this type of forecast returns, how frequently it happens basically. Once you get into the pink period, that's 20 years, so it's a 1 in 20 year period. This one is 50 years here and 100 years there, okay. Right, so this shows you observed discharge levels of the river. And you can see it's been pretty high. Actually, reservoir levels are already very high in these areas, and how they are managed will impact what the next stages are of the flooding and the seriousness of that flooding. But you can see the levels are quite high. They've come down a little bit, and then this is through yesterday, and then you can see the forecast data, the rainfall data, that then starts to fall Tuesday, Wednesday, Thursday, as I just showed you, as Storm Leonardo approaches, and we get those weather fronts coming through, that's the series of rain moving in. Then the discharge level starts to go up by the end of the week. Now we've got a box and whiskers plot here that shows you the spread of the ensemble data. So we've got the mean as the line in the middle, the lower quartile and the upper quartile, and then the two extremes of the data. And obviously the wider, the longer that box and whiskers plot is, the larger the spread in the data. So there is some uncertainty in the exact amount of rainfall, but even as we move up into Thursday, that rainfall data, the knock-on effects on the discharge level of the river are already, even the bottom level are in that pink box, which is a 1 in 20 year event. So we've got pretty high confidence of a pretty major event of heavy rainfall for quite a wide area of Spain as well as Portugal coming up. And we've got the benefit of using this ensemble data. So we've got, even though with the mean you would move into those areas, you can see that actually, although even the lower levels are more in that sort of 1 in 20 year, there are some very extreme higher outputs, extreme outputs showing the potential of quite an extreme event. So I think it's pretty clear that we could see a once in a lifetime event of heavy rainfall and flooding for those parts of Spain and into Portugal. So preparations will be underway to try and mitigate as those impacts as much as possible. And as I said, the flooding risk, there's quite a lot of uncertainty as well as with the amount of rainfall, with how the reservoirs will be managed. There's lots of reservoirs already around, so I'm sure they are negotiating that at the moment. But I just wanted to highlight this potential very major impact brought by that south-shifted jet stream. And that is all thanks to the ensemble data that you can see here. As I mentioned, we've got I mentioned ensembles in the beginning of this as well. And we are the pioneers in ensembles here at the Met Office. We've been using ensembles for over 30 years, and we have just released some new research all around ensembles. And I was joined by Ken Mylne, the sole author of that new research, earlier on today here in the studio. Ken, thank you so much for joining me. This is not your first time on the Deep Dive. You were here just over a year ago with Alex Deacon talking all about ensembles, which is your area of expertise.
That's right.
And you've recently released some brand new research from the Met Office about ensembles, how we can use them, and if people understand them.
That's right. So ensemble forecasting is all about understanding the probabilities, the uncertainties in a weather forecast. And we've been researching this for over 25 years. But we always knew that communicating this to the public or to other forecast users was going to be a bit of a challenge. It's a little bit more difficult to understand how to make a decision with a probability forecast than it is with a straightforward yes-no forecast. So we were always worried about how to communicate that effectively and help people get the most out of these forecasts. So alongside developing the capability, the Ensemble forecast systems, we also did a lot of research, some of it in-house, but a lot of it commissioned out to universities and things, on how to communicate these sort of forecasts. Would people understand them? Testing people's ability to understand them. And in my recent publications, what I wanted to tell people was that actually this is something we've always focused on, and all the overwhelming results of this research is that yes, people do understand it, and most importantly, they make better decisions when you give them this extra information, because it allows them to think about risks and that sort of thing.
Yeah, of course, and everyone has a different appetite for risk, don't they?
That's right.
Not everyone, some people don't want it to rain at all, but other people, if you're just going for a run, you might not mind if it rains just a little bit,
It
for
depends
example.
what you're doing.
Yeah.
If you're dressed up in your best clothes, you worry more about getting wet than if you're just taking the dog for a walk, for example.
Yes, exactly.
So, yes, even for any one individual, it depends on the circumstances what your risk appetite is going to be.
So this is all about ensemble forecasting, potential probabilities of different weather patterns, of different outcomes, and the risk of things happening. Now, for those who watch regularly, you will have seen ensembles quite a lot, and you'll be quite familiar with them. But for those who are new to the idea, we'll just do a quick overview of how we get that ensemble data, what it really means. So this shows us the sort of the timeline of how the forecast changes in an ensemble forecast. Do you want to go through the graph?
So when we're creating a weather forecast, the first thing we do is collect together all the observations from all around the world of what state the atmosphere is in right now, and we put these all together in our computer to come up with a computerized picture of the current state of the atmosphere, which is sort of here on the timeline at the beginning. And then we use the computer model to start from that and calculate forward in time what the forecast is going to do. And so in what we call a traditional deterministic forecast, where you just do that once with the computer, we show that with this sort of pink line here. But we know that actually the atmosphere is what we call a chaotic system, so it's actually very sensitive to small differences in that start condition. We can't ever know exactly what state the atmosphere is in everywhere. We've only got so many observations.
Yeah.
And because the atmosphere is so sensitive, sometimes a small error in that can lead to a big error in the forecast. So what we do in an ensemble forecast is, instead of just running it the once, we make some small changes to this initial state. And then we run lots of forecasts as shown by all these yellow lines. Lots of what we call ensemble members. Each one of these is a complete computer forecast of the atmosphere. And then at the end of it, we get out a whole range of temperatures in this case, but it could be any other element of the weather. And we get a range of different forecast values from which we can try and estimate, well, what's the most likely temperature? But what are also the extreme possibilities that might happen? And that can be quite important for capturing extreme events.
Yeah.
And also we can also get, just for that deterministic forecast, we can get a measure of how confident we are in it. Sometimes, as you see here, they all cluster quite close together and we can be quite confident. The further ahead we go in the forecast, the more likely it is that they diverge and become more different.
And we actually look at a graph really similar to this, often with the ECMWF ensemble data in our deep dives. We've got that data in here. And when you're looking at the temperature trend into the future, you can see, not only the potential outcomes, but the chance of them happening and the extremes as well. And it does vary, around the country as well as to the confidence. It depends on the situation, really. It doesn't always look like that. Sometimes actually you can have quite good confidence to a later time range, can't you?
So one of the things you can get out of this, suppose this is temperature, so supposing this horizontal line here is the 0 degrees freezing temperature line, then you can look at how many of these members are below that and estimate how probable is it that the temperature is going to fall below freezing, how likely. And then, now in this case, if that's the line, it's only one member out of all of these, so it's a low probability. But of course, freezing temperatures have a particular impact
Yes.
So it's important to know how likely that is to occur for people to make decisions.
And it gives you a measure of probability, likelihood. You've obviously got the most likely situation, you've got less likely situations, but it doesn't mean that the less likely ones are not going to happen. There's still an option.
Here's a realistic scenario that leads to that. So yes, that's absolutely a possibility.
Yeah, I think that's always an important method. It gives you the most likely, but it's not definite, even if it's a quite high probability. But obviously,
and we'll show one or two examples in a minute exactly how that can work.
Yeah, so we've been doing ensemble forecasting for a long time. We're pioneers in ensemble forecasting here at the Met Office.
Yeah.
And this new research you've done you went into the benefits of it and how we're using it to benefit us. So we do have here a situation when it was used by forecasters. A very famous situation that all will remember for this time of year, the beast from the east.
The beast from the east forecast, yes. Now it is a few years ago now.
Yeah.
But I've used this just as an illustration because it's a lovely example. Now the first thing when you look at this, you look at we've got 18 different pictures here of individual weather forecasts all for the same time. And there's just a huge amount of information there that's really hard to get your head around, which is why we need to try and summarise this information into things like what's the most likely or what's the probability of something happening or something like that, because that's just too much information to get hold of.
Yeah.
But the other thing that's nice to look at is this, is because there's two different things in here which are very different in how likely they are. So the first thing I point out is up the east coast of Scotland and then the northeast of England.
First of all, actually, we need to just say what this is showing.
Right.
So we've got the 6 hourly snowfall accumulations here, basically, and every postage stamp, as we call them, because they are a little bit small, is a different ensemble member showing various outcomes at 81 hours ahead, isn't it? The spread of the different outcomes once we've varied those initial conditions. Carry on.
So three-day ahead forecasts of the amount of snowfall. Thank you, Annie, for stopping me on that.
No problem.
So all up and down the east of Scotland and the northeast of England, we've got this stream of showers coming in off the North Sea in an easterly wind and dumping snow all the way down that coast. And you can see that almost every single forecast in here is forecasting something along those lines. So we can be really, really confident about that because all the ensemble members are agreeing on it.
Yeah.
And that allows us actually to issue nice early warnings with high confidence.
Yeah.
And that's actually what was called the beast from the east. The beast from the east was this cold easterly wind that was blowing across. But then the other thing was that we became aware of the possibility that a cyclonic storm, a low pressure system, was going to move up into the southwest of the country, hitting up against all this cold air and produce a big dumping of snow into the southwest of England. But if you look at that in these pictures, some of them don't hardly have it at all.
No, like for example
this one up here, and the one next to it. Other ones have big areas of very heavy snow.
Yeah, that one really stands out.
That one really stands out.
And this one here as well.
But also, if you look at them, there's quite a big variety in where they've got them. This one's got it going up into Wales rather than into southwest England. So actually, yes, real possibility of this storm happening, but a big uncertainty about exactly where it's going to be, where the big impacts are going to be. So on this particular example forecast, you've got a high confidence event and then a low confidence event, but one which, if it does happen, is going to have a really high impact.
Yeah.
So what we'd like to do is give people as much early warning of that risk as possible, but we can't say it's definitely going to happen.
No, but we did give warning, didn't we?
So
this was 3 days ahead.
Yeah,
so what did we do?
So this is the warning that was issued that 3 days ahead.
Yeah.
And it's a yellow warning. Now,
quite broad. It's
quite a broad area.
Yeah.
It's taking in South Wales and the whole of southwest of England.
Yeah.
But what people often don't see in the warnings is this matrix, this risk matrix that we use. To get to see this, you have to go to the Met Office website and dig into the details of the warning, but it is there. And so the warnings that we issue, they're always a combination of the potential level of impact and then how likely that is to happen.
Yeah.
Now, of course, obviously the ensemble forecast is a really important tool for doing this likelihood bit.
Absolutely.
But when the forecasters are trying to decide what warning to issue, they think first about how severe could the impact be. And that decides which column this tick's going to go into. And then they look at how likely it is going to be. So in this case, they were 3 days ahead. We had this ensemble forecast showing a few members showing a possibility of a really severe snow event, but most of them not showing it. So they went for a high impact column, but a low likelihood. And they were able to give this warning 3 days ahead. Subsequently, of course, as we got closer to the event, the confidence became higher, and so it actually ramped up up this column into amber and eventually into red.
Yes.
But I just like to illustrate this as a way that we can use the probabilities to communicate the risk of what we sometimes call a hill event, a high impact, low likelihood event. And allows us to give earlier warning so people could start to be prepared.
Which is a huge benefit, and of course, that sometimes the situation does then follow one of the other likely situations. But if you can give that notice and then we can follow the steps, that's the benefit of our warning setup, that it's impact based and likelihood based, so not just a threshold based. And previously, if we just had the deterministic output, they might have seen something, if we go back to the postage stamp, if they'd just seen something like this come out, they would have had no idea that there was the potential for...
No, if you just had a single forecast and it looked like that, there's no warning at all of a potential big event in the southwest.
It would be, at very last minute, maybe the next day there'd be there might be signs, and then it might just pop up just a day before, and then no time to prepare. So
the ensemble forecast is a huge help to our forecasters, because it lets them understand what these risks and uncertainties are, and then find all sorts of ways of communicating it to the public and to all our other forecast users, as indeed you do on a lot of these deep dive forecasts.
Yeah, we do. We're a big fan of ensembles, and you can see why. This is one example of the many, many uses of ensemble forecasts. So this is how we use them, and you say that people, the general public, do understand probability. They do make better decisions when they have... So
let's talk a little bit about some of the research that we did just to demonstrate that to people.
Yeah, so there was a second part to your paper that demonstrated that. Is this the best...
let's look at that one.
A way you did that.
So we've run lots of different experiments working with different groups and things, but this comes from one that we ran ourselves in collaboration with a student who we brought in for 6 months to do this experiment for us. We called it the weather game.
The weather game, I like that.
Yeah. So we called it that because we actually ran it as an online game.
Okay.
That in order to try and get a lot of people to test it. Some of the other experiments we'd done in universities and pulling a group of students together to answer some questions, and we'd have a couple of hundred students taking part or something, which allowed us to test a bit, but it didn't allow us to go to test lots and lots of different things, and it also was a fairly specific group of people.
Okay, yeah.
This was trying to get to the public involved, to get a much wider range of educational backgrounds and gender mix and everything like that, and to get a large sample so we could test lots of different types of presentation of the forecast. So what we did was we gave people a presentation of a weather forecast and asked them to make decisions from it. In the game, it was to help an ice cream seller decide when and where to sell his ice cream.
Okay, yes, very
they
important.
had different weather forecasts.
Yeah.
Some people would just be given a really simple deterministic type of forecast like this one up here. Other people would be given more sophisticated forecasts that included probability information.
Okay, so it varied as to whether there was just a symbol with a few words, or an umbrella and a level, a percentage, and then this is a sort of another way of showing
another way,
that.
sort of completion bar type thing, showing how likely something was to happen. So different sort of graphical or numbers and things to communicate the thing. And so we compared how good the decisions people made according to which type of presentation they got.
Right, okay.
And the outcome of all this research was, first of all, that, I mean, the most basic sense, that you give people more information, you give them the uncertainty information, and they make better decisions. Not quite so much with this one, but with the temperature one, which was presented a different way. Really interestingly, the most complex and most apparently difficult to interpret presentation, people made the best decisions. So we weren't confusing people by giving them more complex information. They were still making better decisions. But out of this one of the really interesting things was, you can see in some cases we've got various symbols and things to represent rainfall.
Yeah.
We've got this graphic. Sometimes we use a word to describe how likely something is.
Yes.
Sometimes we use a number. And one of the key messages was that if we combine a number with a graphic,
yes,
that's the best overall thing.
Okay.
It's interesting because some people are more mathematically minded. Some people love numbers and really feed on them. Other people get scared of them or hate them, just don't like numbers. And they think, oh, that's mathematical, I don't understand that.
Yeah, they switch off, they think that's not for me.
But by combining the two, you capture the best communication for everybody. It works for one part works for some people, another part works for other people. And so one of the key messages of this research was combine numbers with symbols or descriptive words and things to get the best overall communication to the population as a whole.
So people can get the idea of what's going to happen and make those better decisions with the most the best information. So at the moment we have sort of symbols on the app, and how much of that is fueled by Ensemble data already?
Oh yeah, well, first of all, of course, in the app, when you look at the forecast for your local wherever you live or wherever you want the forecast for, one of the things we got in there is a chance of rainfall.
Yes.
Which is given as a percentage number. And that's the only actual probability number we give at the moment. But note that we don't call it probability, we call it a chance of rain. And that's another thing that came out of research, is the word probability sometimes puts people off because they think, oh, that's mathematical, I don't understand that. But you say chance of, and the people are much more comfortable with it.
Yeah.
So use of language is important. And everything else that's in there, the temperatures, the wind speeds, that sort of thing, whereas they used to be derived from the latest deterministic forecast, just the latest single run of our model, now they're actually derived from the ensemble and showing what's the most likely value in the middle of that distribution of all those members. What's the most likely temperature and wind speed? So that's just more likely to be right. So it reduces the risks of an error. I would like to see us in the future starting to communicate more information around that.
Yeah. We
could have probabilities of heavy rainfall as well as probability of rainfall. We could have probabilities of high wind speeds.
Yeah.
We could just give a range of uncertainty around the temperature.
Yeah. What's
the highest and lowest it might be, as well as the most likely. Those sort of things are under discussion and maybe brought in the future, but they're all possibilities of how you could communicate more from the ensemble. And
obviously, as we move to more longer range forecasting, something that we're developing in the Met Office at the moment, you will need more of that probability because you can't use the current method of just showing a symbol with a 1% chance for a whole day at a 2-week time lead. So accurately anyway.
We're looking to introduce week 2 forecasts fairly soon.
Yeah, in the coming months.
But one of the things that we can't do with that is give the sort of 3-hourly or hourly breakdown of detail that we've been used to doing for week 1, because it's just not predictable. And if we tell you that, we're kidding you and we're kidding ourselves, because that level of detail is not predictable. So we're looking to use whole day summaries of things like how much of the day is it likely to be raining for, and that sort of thing. What are the likely maximum minimum temperatures for the day, but not giving you a breakdown of how it varies through the day and things like that. Yeah. So we're getting more of a daily summary of the weather.
Yes, and your research also looked at different ways of showing the same thing.
That's right.
Yeah, we've got this image as well, showing a few different things. We've got Yeah, the 70% chance of rain. They are at 75% chance of rain and a 30% chance of rain, I guess, as well.
As I say, I recently published these 2 papers.
Yeah.
First of all, about the introduction of ensembles, why we do it, some of the ways we can use it. And the second paper is all about all this research that we've done as to how to best communicate this uncertainty information. These 3 examples are just ones that I've come up with myself to put into that paper, but drawing on all that research that's been done on best ways to communicate this sort of information. And so using some of the ideas I've just been talking about. So this first one here, it's very, very difficult. People are used to seeing in week 1 on their app that we'll give a weather symbol for each hour or each 3 hours, or one for the day, indicating what's the weather going to be like at that time. But into week 2, we really can't do that with any confidence.
Yeah.
But
it'd be giving people false hope, wouldn't it?
Exactly. Because there's too much uncertainty.
Yeah.
But we could, for example, show some alternate symbols with using the ensemble to show how likely they are.
Okay.
So in this example, for example, we could say 70% probability of rain, 30% probability of dry.
Yeah.
And actually, just giving those 2 together, that the 30% complements the 70%, helps to understand people to understand what 70% means.
Yeah, you're thinking, oh, 70, because sometimes the chance of rain is if it's a low percentage, but still the sort of the heavier rain symbol, people think, oh, that's only going to be lighter rain, actually.
Yeah, that's right.
So it's interpreted in different ways by different people.
So it helps to communicate what the 70% means. That it's 70% chance it's raining, 30% chance it's not. So that's one way of doing it.
Yeah, that was a good one. Yeah, I like that one.
A very familiar graphic to lots of people is the idea of a pie chart, where they're used in lots of different things. But so using a pie chart to indicate a 75% chance that it will be raining, 25% chance it won't be. Again, the 2 things complement each other, so it's just another way of doing the same sort of thing as this, really.
Yeah.
But a nice compact way of showing how likely it will be that it'll be raining.
Yeah.
The last example, and they're all trying to do the same sort of thing in just different ways, this is actually drawing on lots of the research and methods that have been used in medical spheres.
Yes.
And often been used, for example, probably with a lot more icons than this, sometimes an array of 100 little human beings, and showing if you have this particular drug treatment or something, that maybe 5 out of the 100 people will benefit or even maybe have their lives saved by this particular treatment. But by using this set of icons and showing how many out of that, it's been found to be a really effective way of communicating messages to help people make decisions. So I took that and thought, well, we don't want to show 100 different weather symbols for a particular weather forecast, but we could do it with 10, say. So here, a 3 in 10 chance. Actually, that's just another way of saying 30%.
Yeah.
The different wording might work better for some people. Still using the word chance, not probability. 3 in 10 chance of rain tomorrow, and then illustrate it with this 3 out of 10 symbols showing it. And you think about that, equally the pie chart one, once people start to get familiarity with this idea, you could expand them a bit further. You could have more than 2 different types of symbols in there.
Yes.
You could have, say, 2 with rainfall, 7 without, and maybe 1 with a thunderstorm.
Yeah. Or if it's sort of marginal, if it's going to be snowing or raining or sleet, you could have a rain, a few rains, a sleet and a snow, like just to give you
the possibilities are almost endless, depending on the weather situation. But you could have more than 2 segments in your pie chart as well.
Yeah. Yes, very true.
So these are just some ideas that I'm throwing into the pot of ways that we as an organisation could communicate these to the public, and actually we'd love to have feedback from the viewers on which ones they like.
So have these been tested in your research? Are these things that came out of the research as potential ideas
These have
moving
not
forward?
been tested explicitly themselves. These are ones that I have pulled together from my paper on drawing on all the research we've had as to some proposals for ways that I think the public could understand them and make good use of them. But we'd love to have feedback.
Yes, we absolutely would. Yeah, so if you've got any thoughts and feedback on Ken's suggested alternate symbols, the pie chart, the icon array, just a few initial ideas on that, then yeah, let us know in the comments. We would love your feedback. We know that, as we've said a couple of times, you are the deep dive audience are primed for that Ensemble weather data, but we want to make everyone else at home, those not watching the deep dive, although they should be, to be able to use that Ensemble data as well, because as you said, it does mean that you make a better decision,
yeah,
and you can actually understand it. The general public can understand probability, which is fantastic news, because it means that we can give more accurate forecasts and more useful forecasts.
Help people make better decisions.
Yeah, exactly, for even further ahead as well. Yeah,
and
so
we really are looking at this right now as to how we're going to communicate things for week 2 in particular in the forecast on our webinar app. So if you tell us what you like, you might see it there in the future.
Oh, that's great. What an opportunity. Don't miss out. Yeah, Ken, thank you so much for going over all your latest research. It's really exciting, really interesting stuff. Thank you.
It's been a pleasure.
Yeah, and thanks so much for watching at home. Make sure you leave your comments, ask your questions. We'll be going over them in the live as well on Friday. And if you are looking for, if there's any sign of any dry weather in the forecast, make sure you check out the 10-day trend tomorrow with Alex Deakin. But that's all from us today. Thank you so much for joining us. Bye-bye.
Bye.